Hello everyone, welcome to Cyber Wisdom. So today we're gonna talk about Checksum. I know I have a short video about it in my channel, but I promised to make a second video, but it was too long, so we're just gonna do it in quick form. So I hope you're gonna learn from it. So Checksum. Checksum is a way to validate that data was transformed correctly without missing data, without corrupted data. So let's try and give a simple example from our day to day and grow up until we see it in computers. So let's say we have person A and person B. Person A asks person B, how are you? But now we are also creating a new language. We are in a world that half of the people doesn't hear that good. So we want to make sure that the other person can validate that he understands what we tell them. So we're also adding in the end age AY. Okay. So now person B. Oh. So now person B hears it and is saying, okay, so I heard how are you, and I also have these three letters. Do they match to the words? Yeah, and they match. So he heard correctly and everything is okay. But what if person B heard something like how are they? And he also tells him in the end, hey. So now we have a problem, right? Because we have age, we have A, but Y and T doesn't equal. And what about if he also only heard how? But we have in the end these three letters. So we have age, but we don't have A and we don't have Y. So now person B can tell person A like, what? Right? Or come again? So this is a way to validate the data is not missing or corrupted. Let's take a look at computers. So here quite the same, we have computer A and computer B. So let's say computer A sends to computer B the numbers 12, 10, 50. But we also want to make sure that we have the correct data, right? So he also adds in the end, let's say it's in parentheses, 72. Why 72? Because we decided on a checksum method that what it's doing is taking the numbers and adds them up. Oh, that's a cool feature of iPad. So now we have, am I wrong? What? That's 72. I don't know. So now we have this number as the checksum. So if we sent like B got only 10 plus 50, right? Which is not 72. Let's let him solve it. Yeah, 60. And which is 60 and not 72. So B can say, okay, but I got 10, 50, 72. So something is weird. So this is a method of computers to do it. It's not a real method, of course, but just to get down a bit more technical. So before we jump into the next, the most common technique, I want to talk about bitwise operators. So binary data, as you probably already know, is digits of 1 and zeros. And we can do some math operations, not exactly math, but operations on the digit itself. So let's take a look about some of the operators. So we have the operator OR, which in binary is like saying plus. So if you do okay, so we can take a look about it as 201, right? But we're talking about binary, so we can also add the binary numbers itself. But now I'm talking about OR, which is not a math equation. So OR, what it does is saying, if I have 1 and 1, give me 1. If I have 1 and 0, give me 1. If I have 0 and 0, give me 0. So OR is always telling, give me at least 1, 1. So what O is doing, so yes, we have this and we have this. He's comparing, bitwise operators are comparing each digit to each digit, right? So now we have 1 and 1 gives 1, 1 and 0 gives 1, 1 and 0 gives 1, 0 and 0 gives 0. So the answer is 1, 0, 1, right? And let's take a look about the next one, which is AND, which is like multiplication. So AND, also comparing digit to digit, so we have 1, 0, 1 and 1, 0, 0, and we multiply but like AND. So AND is saying, give me 2 ones. Only 2 ones give me 1. So 1 and 1 give 1, 1 and 0 give 0, 0 and 0. Okay, so here we have 1, like, 1 and 1, which is 1, 1, 0 and 0, which is 0, and 0. We have another operator, which is quite simpler, which is not. It's an operator for 1, not 2 numbers, but only 1. It's just doing the opposite. 1 becomes 0, 0 becomes 1. So if you take a look at 1, 0, 1, we do it like a not, we get 0, 1, 0. And the fourth one is XOR. XOR is a bit more complicated. It also looks like this. XOR is saying, I don't care if I have a 1 or I have a 0. I don't care about the value of the digit. I only care if I have 2 different digits. So 1 and 1 gives 0, 0 and 0 gives 0. But 1 and 0 are different, so we give 1, and 0 and 1 is different, so it gives 1. So if you take a look again at 1, 0, 1, and 1, 0, 0, we'll have 1 and 1, which are the same, so it's 0, 0 and 0, which are the same, it's 0, and 1 and 0 is 1. I don't know what all those boxes are. Leave me alone. Okay, so this is so. So now we can move on to some more complicated checksum method, which is called CRC, cyclic redundancy check. So we have again computer A. I don't have here the objects, but let's do 2 squares. This is computer A, this is computer B. Pardon for my terrible drawing. So now computer A and computer B are deciding on a divisor. The divisor is a binary number. Let's say it's 4 digits. I don't know if it's usually 4 digits to be real, but let's decide it's going to be 4 digits. 1, 0, 1, 0. So now we have the divisor. And also A sent B the binary data 1, 0, 1, 1, 1, 0, 0, 1, 0. And now computer A wants to calculate the checksum, which is the CRC, using CRC, add to the data itself the checksum, and computer B can calculate the checksum again and see if it match. So how now we calculate the checksum? So while dividing, but not like a normal dividing, we're using XOR on the entire binary data using the divisor. So how it looks like is we take our binary data and we divide with the divisor, which is 1, 0, 1, 0. Okay, now we want to do the calculation, right? So we divide the binary data every time we have a leading 1. So let's take a look what it means. So now we have this leading 1 right here, right? So we divide with the divisor and we get the solution using XOR, which is 0, 0, 0, 1, and then we take this one, 1, 0, 0, 1, 0. And now we divide again in the leading to the leading 1. The leading 1 is this one, right? So now we divide starting from here, 1, 0, 1, 0, and we divide. And we get again 0, 0, 0. Here is 0, 1, 1, 0, 1, 0. Now the leading 1 is right here. So again, we're doing 1, 0, 1, 0. Get 0, 1, 1, 1, 0. And here is 0, 0, 0, 0. And again, we have the 4 right here. 1, 0, 1, 0. 0, 0, 0, 0, 0. And here we get also 0, 1, 0, 0. All right, so now we don't have, if we start the divider right here, we have a missing digit, right? So this is where we stop, and this, the reminder, is our CRC. So now the reminder is 100, which is the CRC result. So this is a way that now when A sends data to B, it's sending 1011101010. And let's say this is how many bits? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not really a number to send, but let's assume it is. So computer B knows that he's going to get 9 bits, but also in the end, he gets 100. So now computer B takes only the first 9 bits and calculate the CRC using the same method. He gets 100, and then he can compare. So now he knows if he got the correct data or not. So this is basically it. This is, I think, the most common checksum technique, where you have more techniques as hash to the data, which is SHA-1. Oh, come on. SHA-1, SHA-256, MD5, and more. But I mean, to teach this is quite a different topic, but this is the most common one. So I hope you enjoyed. Leave any question if you have. I promise I do my best to answer. And that's it. Follow for more.